Next is the command receiver and the controller on figure 1128. It receives the instructions from ground station and controls the satellite functions and corrections and adjustments. As you can see from the TTC antenna, the command receiver, the control unit or the CPO, memory, and then it will be passed on the control signals to all subsystems. Attitude control subsystems. All satellites contain an attitude stabilization subsystem with built-in jet thrusters for making corrections to the attitude of the satellites by the way of the command and control subsystem and the onboard computer. The attitude stabilization subsystem receives signals that fire the appropriate thrusters at the proper time to achieve an adjustment in attitude. It simply maintains the correct orientation in space and uses thrusters and control signals that adjust the pitch, yaw, and roll. Its importance is that it ensures the antennas point correctly and solar panels face the sun. Antennas. All satellites have one or more antennas used for receiving signals from the ground station and transmitting information back to the ground station. Some antennas have a dual function. Numerous antennas are generally required because of the various satellite requirements. So its function is used for receiving signals and transmitting signals. Some antennas are dual purpose and multiple antennas are often required so that it can function very well and simultaneously. Next is the applications payload. All satellites have an application subsystem composed of specialized components that make the satellite useful for its intended purpose. For the communication satellite, this subsystem is the transponders. So, it is the main functional part of the satellite. The payload is equals to the transponders. Next is the Earth station. The Earth station or ground station is the terrestrial base of the system. The Earth station communicates with the satellite to carry out the designated missions, and the Earth station may be located at the end user's facilities or may be located remotely, with ground-based intercommunication links between the Earth station and the end user. Next is the ground station organization. A ground station organization is a facility on Earth that transmits signals to satellite or the uplink and receives signals from the satellite and or the downlink. General block diagram of an Earth station. It is simply the ground-based system that communicates with satellites. So its main functions is to send signals or the uplink and receive signals or the downlink. So as you can see from the antenna to the diplexer, BPF LNA, demodulator, modulator, driver and BPF and back to the antenna. Next is the receive substation. The downlink is the receive subsystem of the Earth station. It usually consists of very low noise preamplifiers that take the small signal received from the satellite and amplify it to a level suitable for further processing. The signal is then demodulated and sent to the other parts of the communication system. It receives a weak signal from the satellite and amplify using low noise amplifiers or LNA and converts frequency or also called the down conversion. Then it will demodulate the signal. Here's a block diagram of the single converter down converter. So from the LNA, which transmits 500 megahertz to the BPF, then the mixer to the BPF. It is called a single converter down converter because it has only one path from the LNA to the BPF. Next is the dual conversion down converter block diagram, which has the RF tuning and the IF tuning. The RF tuning is the radio frequency tuning and the IF tuning is the intermediate frequency tuning. And then the typical down converter arrangement, it's only the arrangement of the down converter from LNA, the other parts, the DC, into the crystal oscillator to the IF panel. Next is the transmit substation. The UP-Link is the transmitting subsystem of the Earth station. It consists of all electronic equipments that takes the signal to be transmitted and amplifies it and sends it to the antenna. It simply means that its process is to input signal, then modulate, then frequency up conversion to the amplification, and then transmit it via antenna. IF input from the down converter then goes to the demodulator PM or QP SK, then demux, then to the baseband signal, and it will proceed to the demodulator, then to also to demux, then to the baseband for additional circuits as required. Here's another typical GCE transmit circuits. It's like the previous one. Typical GCE transmit circuits. In the typical UP converter, the IF tuning and RF tuning again from the IF from the modulator, frequency synthesizer BPF, LO BPF to the final RF. While here in figure 1136 is an RF combiner and power amplifiers. From the modulators and GCE to the UC, then it will go to the RF combiner, SWIPA to the main, HPA, then SW, and then to the antenna. Next is the power substations. Most earth stations receive their power from the normal AC sources or the alternating current sources. Standard power supplies convert the AC to DC voltages required to operate all subsystems. However, most earth stations have backup power systems. So its function is to supply power to ground systems, and it uses AC as mains and has backup systems. Next is the telemetry and control subsystems. The telemetry equipment consists of a receiver and the recorders and indicators that display the telemetry signals. The signals may be received by the main antenna or by a separate telemetry antenna. It receives satellite status data and displays system performance. At the end of this chapter, the common uses of satellite communication is the TV broadcasting, satellite phones, navigation, and surveillance. As a final summary, let's have a quick review. A single conversion transponder is one frequency shift. Double conversion transponder is a two frequency shift with better quality. Then regenerative is to demodulate, remodulate, and clean the signal. Then the multi-channel subsystems has many signals in one bandwidth. Then the subsystems are the power, TTC, attitude, antenna, payload, and the earth station handles uplink and downlink signals.